Hi friends, after finishing up with the temperate cyclones, we will do the new and the more important topic of the tropical cyclones. Now these tropical cyclones are as the name suggests, they occur in the tropics. What do you mean by tropics? That is in the area between 23.5 degrees north and 23.5 degrees south. But they happen in the tropics but not at the equator. Why do not they occur at the equator? We will see later on while doing the conditions required for the tropical cyclones. Now these tropics are home to around 40% of the human population. So 40% of population of the world stays in the tropical regions. Out of this 40%, 55% of the world's children stay in this region. The fact you can use it anywhere, but not only just restricted to geography. That is the 40% of the world's population stay in the tropics, and out of this, and 55% of world's children are belonging to the tropics. And this in this tropical regions of the world, where most of the population stays, where most of the young population and small population stays, are violent storms which are known by different names. For example, they are known as cyclones in Indian Ocean region. They happen in both the western part of the Indian Ocean and in the eastern part of the Indian Ocean. That is, in the Indian Ocean they are known as cyclones. In Australia they are known as willy-willies. They are known as typhoons in China. They are known as Baigo in Philippines. They are known as Taifu in Japan. And they are known as hurricanes in USA or in North America or in Atlantic and Pacific Ocean. So these are the different names which are given to the very severe, very destructive nature, that they are classified as a natural disaster. The severe, destructive, low pressure centers or storms which develop in the oceans here in the tropical regions are known as tropical cyclones, and these are known by different names such as hurricanes in USA. Now this is a preliminary question, that they are known by different names such as hurricanes in USA or in the Atlantic Ocean and the Pacific Ocean region, that is near North America. They are known as cyclones in the Indian Ocean region. They are known as willy-willies in the Australia. They are known as typhoons in China, Bagao in Philippines, and Taifu in Japan. So these are the tropical cyclones which affect the world. Now you remember this fact, that is hurricanes means USA. Cyclones we call whatever the cyclones affect India, we do not call them as hurricane, we call them as cyclones, because they affect the entire Indian Ocean. They are known as cyclones. For example, cyclone Phalian, hurricane Katrina. So these are the different names, and they have been still classified, that they have been given special names, as generally girls' names are used. Who gives them names, what are these names, why are the names given, I will do it as a separate topic. Known as willy-willies in Australia, typhoons in China, Bagao in Philippines, and Taifu in Japan. So, how does this tropical cyclone originate? Or what is the origin of a tropical cyclone? The tropical cyclones which are present, they act as a moist heat engine. What are they? They act like a heat engine which originates over warm oceans. So these are actually act like a heat engines over warm oceans. Warm oceans. Now what do you mean by heat engines over warm oceans? Means they are driven by the heat which is a moist heat. Why? Because it is originated over oceans. Why they are driven by the moist heat? Because the latent heat of condensation which is required, which is given out when there is condensation process, means when there is a rainfall, when there is a cloud formation, when there is a little bit of precipitation, the heat is given out. We know this. So it drives this heat engine a bit more. Initially, I'll just give an overall rough idea of how these tropical cyclones originate. Initially, there is a vast difference between the sea temperature and temperature of the continents. So when the summer season comes, the continents are heated more as compared to the oceans, while the oceans take up time to get heated up. When these oceans, in the late summer, when they get heated up, a low pressure center develops over the oceans. Now because this low pressure center develops over here, the winds from surrounding regions are sucked into this low pressure center. Means winds from the surrounding region are blow towards this low pressure centers. As these winds blow towards the low pressure centers, because of the low pressure, they start rising upwards. When the winds rise upwards, why the winds rise upwards? Because obviously in the low pressure the air rises upwards. When the air rises upwards in the low pressure, what happens when the air rises upward? It starts cooling and starts condensing. That is, there is a small bit amount of condensation occurs. Due to condensation, heat is added to the surrounding atmosphere. You know that that during evaporation heat is utilized, but during condensation the heat which is stored in the vapor, it is given out. So as a result, there is a latent heat of condensation is given out. Due to latent heat of condensation being given out, the area gets heated more, and there is a further development of this low pressure. That means this low pressure gets intensified. So initially a small low pressure is developed somewhere in the ocean. After the low pressure being developed, air from surrounding regions are sucked into this low pressure. Due to the air coming in this low pressure, the air rises upwards. As the air rises upwards, there is a condensation of the air, and due to the condensation of the air, the latent heat of condensation is added to the atmosphere. Due to the addition of this latent heat of condensation, the low pressure will further intensify. As due to the low pressure being further intensified, more wind from the surrounding region will come up and it starts vertically rising. When the wind starts vertically rising, the further condensation, latent heat of condensation results into the wind rising from the surrounding region, vertically rising upwards. When the wind further vertically rises upwards, obviously in this region there is a formation of a cloud which is known as a cumulonimbus cloud. Due to formation, this cumulonimbus cloud develops where the winds rises upwards on both the sides. So there is a development of this cumulonimbus cloud. Huge wall of this cumulonimbus clouds develop, and when the cumulonimbus clouds develop, why are they developing? They are developing because the air is rising upwards. When this huge wall of cumulonimbus cloud develops, it gives rainfall, and then it gives very, very heavy rainfall along the cyclones. So and at the top of a cyclone there is some special kind of an anticyclonic circulation which makes sure that air which rises upwards is thrown in different directions. So the air from here diverges, it does not settle down in between, it is diverging in different directions. So down ground there is a low pressure, while up there is an anticyclonic condition, that is an high pressure is created. Such a kind of a heat engine, now this is continuously swirling. That means the winds are rising upwards in such a manner And this such kind of an heat engine which develops, which is very powerful, is known as an tropical cyclone. See, here also there is a convergence of air mass due to low pressure, but both the air masses are of same temperature. The air rises upwards, it forms cumulonimbus, huge cumulonimbus clouds, and then they, because of this high pressure, they are diverged into different direction. So this is how the tropical cyclone originates over a moist air. Why moist air? Because why not on the dry air? Or why the tropical cyclone dies as soon as it reaches the ground? The tropical cyclone dies as soon as it reaches the ground because the moist heat supply is cut off, and the tropical cyclone cannot survive without a moist heat. Moist heat will be present only over the oceans. Now, why moist heat? Because the latent heat of condensation and condensation will occur only if there is a sufficient amount of water vapor. And this water is over the ocean. Obviously, it has such a quantity of air which is there over the ocean, has lot of amount of water vapor. Little bit rising of air results into condensation and heat is given out. Further intensification, the air rises upwards, cumulonimbus clouds form, and there is a very, very heavy rainfall. And the cyclones, why are they destructive? The cyclones are destructive because this pressure gradient, that is the pressure difference between this low pressure center and outside somewhere here, high pressure center, is extremely large. So the winds which are blowing from this high pressure center to the low pressure center, they blow with great velocity. How much is the velocity? More than 160 kilometers, reaching up to 350, 400 kilometers per hour. And such a violent high velocity wind has the power of uprooting the trees, destroying the buildings, causing large death of life as well as destruction of property. So such a great heat engine is known as a tropical cyclone. So this is why the origin of a tropical cyclone. Now see in this diagram here. If we look from the satellite, how does the tropical cyclone affects? And this tropical cyclone, when it originates, where does it travel? These tropical cyclones, after originating in India, I am taking this for example, only India. In India, these tropical cyclones originate in the Bay of Bengal region more than the Arabian Sea region. The reason being, Bay of Bengal is more of a warmer ocean than the Arabian Sea. The second thing is, these tropical cyclones, after their origin, they always travel eastwards. They travel eastwards rather than westwards. So if they originate here, they will travel towards India and hit the coastal regions of India. On the other hand, if they originate in the Arabian Sea region, generally they go and hit Pakistan, or they go and hit in the other than that India is avoided if they originate in the Arabian Sea region. But if they originate in the Bay of Bengal region, they come and hit India because they travel northeasterly direction. It is like top which is spinning, and the top can travel in any direction when you are playing with the top. So once you put the top on the floor, the top spins at a great speed and it can take any direction. It can travel in any direction. Same thing is there with tropical cyclone, but mostly they travel. Again, I am saying that they can travel in any direction, but mostly they travel in northeasterly and easterly direction. And because the Bay of Bengal के ईस्ट में इंडिया is there, while on the Arabian Sea के west पे India is there, 99 times they will travel to the eastern direction. So the Bay of Bengal में which storms which originate, they come and hit India, while the storms which originate in the Arabian Sea region, they do not come and hit India and they avoid India. Then why are they so dangerous? They are dangerous because if it originates near India, a low pressure center is created. Because of this creation of this low pressure center, the winds from all the sides will be sucked into this low pressure center. So winds from all parts of India are blown in this low pressure center. anticyclonic condition, anticyclonic circulation or anti-clockwise circulation. So the winds from all over India, all the sides, they travel into this tropical cyclone. And because the winds are also travel with the great speed, these winds which originate on the mainland India, they affect the coastal regions. Jitna nazdik hai tropical cyclone, or the more powerful tropical cyclone is, more powerful will be the winds which will go into the tropical cyclone. Now these winds which are there, they are traveling with they are high velocity winds, and because they are high velocity wind, they cause large scale destruction on the eastern coast or anywhere they can affect. In fact, if a tropical cyclone comes in the Bay of Bengal region, cloudy conditions, rainfall or the high speed velocity winds are even seen in the interiors of the peninsula. Obviously, if you go more near to the tropical cyclone, the velocity, the severity of the winds will increase, and they will be more and more destructive. So this is how, even though it is there in the mid-ocean, in the Bay of Bengal region, but because the winds are sucked like a vacuum pump from all the sides, high velocity winds from India also originate on the Indian mainland, and as I told you, these winds are around the speed of 200 to 300 kilometers per hour. Such winds cause large scale destruction of life and property in this region. So this is how the tropical cyclones are so dangerous. Now we should know that, we already know that why does the temperate cyclone originate, or how does the temperate cyclone originate? You know that the temperate cyclone originates due to convergence of two different air masses. One will be hot air mass, one will be cold air mass. How does the tropical cyclone originate, or how does the cyclone, as it is commonly known as, or typhoon it is known as, or hurricane it is known as, originates? We have seen here now. That is, the low pressure is required, and then the air from all other side will be converged into a point. Latent heat of condensation will be added to it, resulting into intensification of a low pressure, and then further the air rises upwards, a wall of cumulonimbus cloud forms, giving very heavy rainfall. At the top of a tropical cyclone, there is a high pressure center, but on the ground there is a low pressure center. This is what the mechanism is. But as I am telling this, I should also admit that the exact mechanism of the tropical cyclone is still being worked out, because the tropical cyclone is a deadly natural disaster. So we can go and study inside the temperate cyclone, we can study the temperate cyclone and know the exact conditions, but the going into tropical cyclones and studying exactly what are the conditions along with the equipment is more than impossible. It is nearly impossible. So the tropical cyclone is not a well understood phenomena, but as of today's knowledge, as of today's mechanism, as of today's mathematical models, we still have a better idea, and this is the idea of how the tropical cyclone originates. Obviously, then the conditions which are required for the tropical cyclones are very different from the temperate cyclones. Temperate cyclone, the condition is formation of a fronts. Where does the front form? When there are two contrasting air masses, there is a convergence, then it forms fronts. Fronts ke baad there is a temperate cyclone. But tropical cyclones, the condition is very different. So let us do the condition and also do the preliminary questions which are asked. Obviously the mains question will be somewhat direct. So the conditions required for the tropical cyclone. What are the conditions required for the formation of tropical cyclone? The first and the most important condition is there should be large and continuous supply of warm and moist air. There should be large and continuous supply of warm and moist air. Of warm and moist air. That is the large and the continuous supply of warm and moist air. Why the large and the continuous supply of warm and moist air? As I told you, because the warm and moist air is like a fuel which burns this heat engine, that is, or which energizes this heat engine known as tropical cyclone. So where do we get large quantities of not just warm, but you remember warm and moist air? So from where do we get this? Obviously it will come from the oceans. Which oceans? From the tropical oceans. Therefore the tropical cyclones do not originate in the temperate regions. Therefore they originate only in the regions which are having temperature, ocean surface temperature greater than 27 degrees Celsius. Obviously such oceans will occur in between the tropics. So we can write, therefore they originate in the tropical oceans. Therefore they originate in the tropical oceans. Where sea surface temperature is around 27 degrees Celsius. Is around 27 degrees Celsius. Or even you can write greater than 27 degrees Celsius. So minimum temperature which is required is 27 degrees Celsius for the origin of an tropical cyclone. Obviously, therefore, they will originate in the, when will be this temperature required? For example, India, as of today, now this is the winter season in India. So when will they originate? In the winter season or in the summer season? Obviously, they originate in the summer season. In which part of the summer season? During monsoon? Yeah, during retreating monsoon in India. I'm talking only of India. Here your basics will come into play. Your basic says that the ocean water takes more temperature, or the water takes more time, because its specific heat is greater. It takes more time to get heated as well as cooled. Therefore, obviously, monsoon the land becomes very hot, but during the month of September and October, the ocean starts getting warmer. Why? Because it takes time for the ocean to get warmer, because water takes time and ocean is a water body. So therefore in India, it is mostly during summer or late summer, that is during the month of September and October, that is when during this months the tropical cyclones originate. Coming to now this year's preliminary question. If we look at the world map, if I draw the world map here, now if we draw the world map here, and if we see the kind of ocean currents, though we have not done this topic, and this is the equatorial region of the world, if we do the kind of the ocean currents, we'll see that this area to the west, this is an area which is dominated by the trade winds. So the trade winds are onshore over here, while they are offshore over here. The trade winds are onshore. Trade winds are onshore, or easterly winds, they are onshore, while they are offshore on the western part of the continents. If we look here, offshore. What do you mean by, what is the difference between the offshore and the onshore wind? Now looking at an hypothetical continent again. If this is a continent and if it is surrounded by an ocean, if this is a land and it is surrounded by an ocean here, if a wind is blowing towards the ocean, towards the land from the ocean, that is onshore wind. And if the wind is offshore, what will happen to the water of the oceans? If this is an ocean water, if this is an ocean water. If a wind is blowing towards the land that is onshore, it will result into piling up of water over here. So what happens here? Water piles up. While on this place, when the wind is offshore, the water, surface water is removed. The surface water is removed. Now when the surface water piles up, of the temperature of surface water is greater or the deeper water is greater? What will be your a basic observation? On the ocean, will the surface water be more hotter? Yeah, deep ocean mein that water will be hotter. With this fact, I also want to share you one fact and then you can write the answer, you can come to the answer. I am asking you the question whether the surface water temperature is greater in the oceans or deep water temperature is greater in the oceans. With this I am giving you a fact that the sun rays can penetrate maximum up to 200 meters in the ocean water. After 200 meters the sun rays cannot penetrate. The heat is supplied by the sun rays. When the sun rays cannot penetrate greater than 200 meters, obviously the temperature of the sea water deeper will be lesser. The inside water will be colder while the surface water will be greater. As a result, when the wind blows towards the surface, that is what is happening in this part. When the wind is blowing towards the surface, it results into piling up of ocean water, therefore sea surface, therefore temperature increases. While यहाँ पे the surface water is removed on the western side of the continents. The surface water will be removed. And if the surface water is removed, uska place will be taken by deep water from the below the surface. Now if I am removing this surface water, obviously this water has to be replaced from somewhere. This water gets replaced from the water which is there deep inside the ocean, and hence यहाँ पे the temperature becomes cold. If the surface water is removed, cold water from below the ocean replaces this water. And therefore temperature decreases. Temperature decreases. Why I am telling you all this thing? Because again this year's preliminary question was there, why in some of the oceans, for example South Atlantic Ocean or South Pacific Ocean, there is an absence of tropical cyclones or cyclones. And the answer keys unfortunately gave many wrong answers. There was too much controversy of this question that some had the answer key regarding Coriolis force, some institutions gave the answer key about sea surface temperature, while some gave about ITCZ. Confusion. And then students who were scoring very good marks also failed because there were some of the controversial questions as per the students but not as per UPSC, because the answer for this is fairly simple. The answer key which the answer in the answer key which gave the wrong answer for this, and if the student has utilized or used that answer key for taking out the marks, obviously his score is distorted. His or her score is distorted, and if the score is distorted even by a 0.3 marks, then also there is a chance of you not getting into the list. And therefore, the best thing is keep a margin of marks higher. Always be better than the average. And obviously you should also know the right answers. So here, they originate in the tropical oceans where the sea surface temperature is greater than 27 degrees Celsius because they require large and continuous supply of warm and moist air. Now, as I told you of the sea surface temperature on the eastern side of the continents is higher. Why? Because of the piling up of the water, sea water there. On the western side of the continents is lower because of the removal of the surface water. Because the surface water is removed, cold water from below replaces this, and therefore the temperature decreases. Now this is what we call as an ocean current. So the western side of the continents, be anywhere, they are washed by warm currents. They are washed by cold currents. These are Peru current, this is Venezuela current, this is West Australian current, this is West Australian current. What are this? These all are cold examples of cold currents. These all are the examples of cold ocean currents. And because these are all cold ocean currents, they reduce the sea surface temperature. Therefore, this cold current means the cold water is coming here. So they reduce the sea surface temperature, and therefore in this region, though they are in tropics, there is an absence of tropical cyclone. Why? Because the sea surface temperature is reduced to is made less than 27 degrees Celsius. So because of the reduction in the sea surface temperature, there is an absence of tropical cyclones. And what side of an ocean is this? This is the eastern side of the ocean. So the tropical cyclones, if we see, they generally originate on the western side. Here as hurricanes, here as willy-willies, here as typhoons, here as, this is also a western side. Now for India it is an exception because it is a closed ocean. Indian Ocean is only half of an ocean. So India is an exception. But you see the Pacific Ocean ka western side of the Pacific Ocean there is a cyclone. Not on the eastern side, because on the eastern side of the Pacific Ocean there is a cold Peru current and cold California current. We will do it while doing again the ocean currents. Similarly, on the western side of the North Atlantic, there are presence of hurricanes. Not on the eastern side of the North Atlantic. And same with the Indian Ocean. Therefore, we can see right here that as the ocean currents, as cold ocean currents, decrease the sea surface temperature. On western side of oceans, on eastern side of oceans, on eastern side of oceans or western side of continents, or western side of continents, or the western side of the continents. Therefore, tropical cyclones do not originate here. Do not originate. Therefore, the tropical cyclones do not originate. Remember this as one of the most difficult question of prelims 2015 in the civil service examination. This was one of the most difficult concept. That is why there is no ocean current, why there is no tropical cyclone on the southern Atlantic and South Pacific. Now you have to remember one condition is it has nothing to do with ITCZ, it has nothing to do with Coriolis force. The answer here lies in the decrease of sea surface temperature on the western side of the continents. Therefore, there is lack of cyclones here. Why? Because one of the first condition is large and continuous supply of warm and moisture having sea surface temperature around 27 degrees Celsius or greater than 27 degrees Celsius. So this is the first condition. The second condition for the origin of a tropical cyclone is larger value of a Coriolis force. Larger value of Coriolis force. There should be a larger value of Coriolis force. So they will originate only if the Coriolis force is larger. What is this Coriolis force? It is the deviation force. It is the spinning force. So if a tropical cyclone is originating here, low pressure zone, then obviously there should be some kind of an deviation force to take up winds and so that the winds will deviate here and go in this low pressure zone. Now, where is this Coriolis force minimum and where is it maximum? Coriolis force is inversely related to the rotational speed of the earth. Now, and therefore the Coriolis force is minimum at the equator while it is maximum at the poles. Therefore the deviation, because the Coriolis force is minimum at the equator, there is no deviation, there is no spinning movement, there is no circular movement, there is no bending up of the winds near the equator, and while the maximum bending occurs at the temperate regions and in the polar regions in the higher latitudes. But the tropical cyclones cannot originate in the higher latitudes because of this first condition. While due to this second condition, that is because the Coriolis force is minimum at the equator. Again remember, minimum, not zero, because once in UPSC examination, though not civil service examination, but the other examination, obviously the students who write civil services, they also appear for other examination, for example, assistant commandant examination. They had asked this question, that is why there is absence of tropical cyclones at the equatorial regions. One of the option was Coriolis force was minimum and the other option was Coriolis force was zero. There is no zero Coriolis force. The Coriolis force is minimum. So because of the Coriolis force, that is the deviation force is minimum at the equator, therefore the tropical cyclones do not originate in the equatorial regions. That means from 0 degree north to 5 degree north and from 0 degree south to 5 degrees south, the tropical cyclones do not originate. Why? Because the second condition is not satisfied, that is the Coriolis force should be larger. So here you can write the cyclones, tropical cyclones originate between 5 degree to 20 degrees latitudes in both the hemispheres. In both the hemispheres, but they are absent between 0 to 5 degree latitudes in both the hemispheres, that is in the equatorial regions. Because why they are absent? Because the Coriolis force is minimum. Because the Coriolis force is minimum. Because the Coriolis force is minimum. So they are absent here between 0 to 5 degree latitudes, that is in the equatorial regions. In the equatorial regions. Therefore, why? Because the Coriolis force is minimum. So remember, for the tropical cyclones, both these basic minimum conditions should be satisfied. The first condition, large and continuous supply of warm water, is totally satisfied in the equatorial regions. But still, because this condition, second condition, is not satisfied in the equatorial regions, the tropical cyclones do not originate in the equatorial regions, that is between 0 to 5 degree latitudes. On the other hand, the second condition, the higher value of Coriolis force will be greatest in the polar and in the temperate regions. But the first condition is not satisfied, that is the sea surface temperature should be greater than 27 degrees Celsius. Again, this has been a past year question many times. That is why, and obviously if you are having geography as an optional, or even if the optional is not geography, such basic questions can be asked even in the interview stage. That is why the tropical cyclones do not originate near the equatorial regions. So here, remember this. The third is, there should be an upper level anticyclone. There should be an upper level anticyclone. What do I mean by the upper level anticyclone? That means at the height of 9 kilometers to 15 kilometers from the ground, there should be an anticyclonic condition. Why there should be an anticyclonic condition? Because this anticyclone acts like an exhaust fan which pulls up the air above. This anticyclonic conditions, therefore that means here at the ground there is a low pressure, and here at the above there is an high pressure. What does this high pressure do? This high pressure makes sure that the winds do not come and again settle down. The winds are thrown here, that is so that there is a divergence of a wind. What do you mean by high pressure? High pressure means divergence of a wind. Low means convergence of winds. High there is a divergence of a wind. Anticyclones we have not done, we will do it. High pressure anticyclones are just opposite to cyclones. Cyclones means convergence. Why convergence? Because low pressure is there. On the other hand, anticyclone means divergence of a wind. So at that height of 9 to 15 kilometers, there should be an anticyclonic condition. So why? So that there is a divergence of a wind in the upper of atmosphere. so that there is a divergence of winds in upper atmosphere. And lastly, if there is an pre-existing depression is there, it gets, see, if there is already a ocean is very warm, if the ocean is already low pressure is created in the ocean, then it further helps in the intensification of a tropical cyclone. So the pre-existing weak disturbances What is disturbances? Weak disturbances means already a weak low pressure is there, provide more favorable conditions, for development of cyclones. For the development of cyclones. So these are the conditions required for the formation of a tropical cyclone. How they originate we have already done. So, but in this also you remember the most important condition is large and continuous supply of groundwater, and the second is larger value of an Coriolis force. The third condition is upper level atmosphere. Now if there is already a low pressure, what we call as a weak disturbances, it may intensify as a cyclone. It may not also intensify as a cyclone. So this is not that important conditions. So these are the conditions for the development of a tropical cyclone. In the next lecture, we will do the structures, and after that we will do the naming of a tropical cyclone and also the tropical cyclone in India. Till the time we meet again, thank you very much.